Hello everyone. For this tutorial video, I like to talk about what power means in terms of mechanics, as well as give the SI unit for it and the formula for it. Just like work and energy, you may have heard that power has different connotations in everyday contexts. But in physics, like with any science, especially math, it has a more rigorous and specific meaning. Power is defined as P equals W over T, and this means how quickly something does work, which might make sense from the everyday connotations. If you've ever heard of a powerful sports player, like a football champion, or a powerful car engine. Because of the formula for power defined as work done per second, it actually has a specific unit of wattage, named after the engineer James Watt. This strict formula/definition makes it clear that something like a powerful car engine uses more energy more quickly in order to accelerate faster and be more efficient. So, with this new formula under our belt, we can actually solve problems involving power, because we remember the formulas related to energy from previous problems. For example, if we are told that a woman runs up a flight of stairs at a distance of exactly 3 meters in a time of exactly 3.5 seconds, and she has an initial speed of none or 0 and a final speed of 2 meters per second exactly, and that she weighs 60 kilograms. We first set up the problem involving work and energy, and we see it is a simple summation of the kinetic energy at the end and the potential energy between the beginning and end points, by the law of conservation of mechanical energy. So because we know all the relevant details for the kinetic and potential energy, as well as the time between the beginning and end, we plug in all of our numbers to the power formula, and we conclude that she must have exerted a power of exactly 538 watts. This may seem like an unreasonable amount due to its sheer magnitude, but depending on how much you consume beforehand, it is actually possible to do this amount of work that quickly, especially if you are a professionally trained athlete such as a sprinter. Before we discuss how simple machines work, there is one slight thing that is not related directly to mechanics that I'd like to talk about that is related to power, which is how to calculate how much money you can save if you know the power or energy consumption of something in particular. In particular, since we know already that power is defined as how quickly something uses or transfers energy in a given time period, then it should be logical that the energy transferred equals the power times the time interval. And this is exactly the logic behind how something like an electric company bills you, because you will often see it is written as kilowatts per hour, where the kilowatts comes from the definition of power, and the hour comes from the definition of time. So if we are told that a computer has a specific energy consumption of 200 watts or 0.2 kilowatts, and we want to figure out the energy cost after a certain number of days rather than hours, and we have a consistent schedule where we use the computer 6 hours per day, and the exact amount of days we are solving for is 30, and we are given the cost of electricity in general is 12 cents per kilowatt hour, then we plug in every number into the energy equals power times time. But it becomes tricky because there are different units involved in the problem for time, so we have to convert them as necessary. Since we want to figure out energy, we choose that we have to eliminate the days. So we multiply 6 hours per day by 30 days in order to get the overall time in hours, and then we simply multiply this by the wattage given at the beginning of the problem to figure out the energy cost. So now that we know an exact kilowatt hour, we simply multiply by the cost given per kilowatt hour and deduce that it will cost exactly this much. Now that we have successfully demonstrated what power is in terms of energy, we can transition to simple machines, which actually take advantage of the conservation of mechanical energy, which we will see when we analyze situations involving them. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.